Hello, in this video, let's begin discussing how to make a sketch of a polynomial of degree greater or equal to 3. So that means to make a sketch means to make a picture by hand of a polynomial of degree more than or equal to 3. So far we have seen the polynomials of the first degree. Those were straight lines, those were linear. We saw second degree. These were quadratics. And now we will look at the sketch of something that is more than 3, 4, 5, 6, and so on. So what do the pictures of these look like? And each time the highest power is odd, we will have something that looks like this. One arm down, one arm up. If we have the even, these two would look more like a parabola. May have a little bit of a wiggle, but it'll be two arms going either up or down. And when we sketch these, we are looking for the same key information that we looked for the quadratics, but we also have to add more information because the curve has become more complex, and so we need more data points to do this. Now, the first step, when we make a sketch by hand, there are many different templates of what information we need, and different instructors would ask for different information. So this is just an example of one way to do it. The first thing that we may do is we may use our calculator to make educated guess. This may save us time on homework and test when we see that our work by hand does not match the diagram that we see on the calculator. We know that either the calculator input was off, or maybe we did something incorrect in our work by hand, and we need to line up and check, see why the work by hand does not match the picture. So that's one reason to start with the diagram first. Then the second is to use domain and range. These are new terms, and this type of information is optional. Sometimes it is asked for, sometimes it's not. Third is the intersects. This is mandatory, that is something that almost everybody is asking for, and the intersects are the y-intersect and the x-intersect. Now, the next piece of information that is often asked for is the end behavior. The end behavior is also optional, and it simply tells us what happens to our picture as x goes to plus infinity. So here, as x goes to plus infinity, what's happening to the diagram? Is it going up? Is it going up? Or maybe it's going down, or maybe it's going flat. So that's the end behavior as it goes to this end. Also, the end behavior as it's going to the negative infinity. What's happening? Is my graph going down? Is my graph going up? What's going on with the picture as I'm going way to the left? So that's the end behavior. And it simply helps us to see the general shape of the picture. Again, it's optional. Finally, the last thing that we might do is we might use a table of values, that is the x and y coordinates, if we need more data. And that also is optional. So of all the things that you have to provide, the key thing that we need to provide is the x and y intersects, and then the general shape of the picture. And in different tutorials we will look at, in different videos, we will look at each one of these items a little bit closer, and we'll illustrate it with a picture. And now one more thing to mention here is when we look for the x-intercepts, we will be using the fundamental theorem of algebra plus calculator plus division of polynomials. And there is two versions of this division, synthetic and long division. We most frequently will be using synthetic to find the x-intercepts. To find the y-intercepts, we do it the same way we did it with the quadratics. We make x equals 0 and solve. That will find us the y-intercept. And that's it for the general template. So in the next video, let's talk about what is the domain and range, and then we'll start doing the examples and sketching these by hand. Thanks a lot for your time. Take care.